Hello, everybody. Thank you for being here with us. We are here for presenting ECOFACT. ECOFACT stands for Eco-Innovative Energy Factory Management System. But let's not focus on the acronym and let's see what the project is about. So let's have a look at the project in a nutshell. In a big nutshell, actually, because it's a huge project. It's a 12 million euro project. It started in 2020. It lasts 48 months, and it's carried out by a consortium of 20 organizations. This project has been founded by Horizon 2020 program, so by the European Union. And from our point of view, the core part of this project is the digital twin platform based on Forge. This digital twin platform will be the energy and resource management system of the project, and we will see later on what we mean with energy and resource management system. But first, let's focus on the learning objectives of this class. So first of all, the first learning objective is understand how to build up a digital twin platform on Forge, exploiting its relevant APIs. Then we will see how to deepen the knowledge on the whole ECOFACT platform, and especially on the part that is composed by the energy and resource management system, so by the digital twin platform itself, combined with the dynamic LCA and LCC, so life cycle analysis and life cycle cost assessment. Assess the potential of the integrated platform and understand how it could support industrial process optimization, and more in general, learn how European Union is contributing to boost sustainability through this digitalization thanks to Horizon 2020 program. So, but let's start with why. So why have we done this? Why ECOFACT? So basically, we all know that more is inevitable nowadays. So we are producing more and more. We are growing. Population is growing. So we need more cars. We need more streets. We need more buildings. But from the other side, we need to produce more with less because we have less resources. We can exploit less resources. And furthermore, we have to produce more with less consumption of energy, if possible, and especially with less CO2 emission, because we are all aware of the environmental issues we are all facing. So there is a huge opportunity, basically, the opportunity of doing better, the opportunity of doing better and do it differently, because we cannot solve our problems with the same thinking we used when we created them. And this is basically why the European Union has promoted the Horizon 2020 program. The Horizon 2020 program, as a matter of fact, is a program financing innovation. So financing innovation with the aim of cutting greenhouse gas emissions. So financing innovation in different sectors, but with the aim of cutting greenhouse gas emissions. So, as I said before, ECOFACT, that is the project we are talking about today, is part of this program. But as one team, we are working also on other projects financed by the European Union with the same aim. So the final aim of those projects is to cut the CO2 emission. In this case, you can see other projects, as I said. So B4EB, Infinite are two projects where our role is to develop always let's call it the BIM platform, so the platform hosting the BIM models and the BIM models themselves. And the aim of this project in this case is to foster renovation and make existing buildings more efficient from an energy point of view, exploiting thanks to digitalization, thanks to building information modeling. But today we are focusing, as I said before, on ECOFACT. ECOFACT has a different has a different is focused on a different sector. So it's focused on manufacturing, it's focused on industry. As a matter of fact, ECOFACT, the goal of ECOFACT is the optimization of processes, of industrial processes of factories, especially of 4 big factories. We will see later, And as I said before, in these projects, it's necessary a change of paradigm. In this case, in the planning of the processes, of the industrial processes, thanks to the ECOFACT project, the environmental part will be taken care at the beginning, at the very beginning of the planning, and not at the end of pipe. So this is the big change. So taking into consideration as a parameter the environmental issue since the very beginning of the planning of processes. So let's say that at the end, the final goal is work through sustainability, and as one team, as our company, we have always been interested in sustainability issues. As a matter of fact, our logo itself resembles the earth itself, and our motto is transform competencies and technology into value to make a better world, to make a more sustainable world. That's why we have been working in those European funded projects, and not only. But let's stop 1 second before deep diving into who we are and presenting also ourselves. So me, Andrea, and my colleague Alder. Let's have a look at the overall agenda. So first we will start with an introduction, so introducing our company, myself, and Mr. Alder Moriggi. Then we will talk about the project at a higher level. So we will give you a project overview. Then we will deep dive into the solution. So we will see what is a digital twin platform, how is it made, and then we will focus on the next step. So what's next? Which are the future challenges and the call to actions? Okay, as I said before, now let's introduce better the company and ourselves. So, as you can see from the video, we are a consulting company working in different fields. So we are working in building information modeling. We are working in manufacturing. So we talk about Industry 4.0. We are working with the GIS system. So we're talking about Esri system, Esri solution, and we have been doing this since for over 25 years, and we are also one of the top 10 Autodesk Platinum partner at the EMEA level, and that's why we want to also thank Autodesk for the support, and thank for Autodesk for hosting us today and giving us the opportunity to share with you the results of this interesting, important project. So these are our key numbers. So we are a staff of more than 100 people. We have 60K users, more than 60K users, total revenue of about 37 millions, and 11 locations spread all over South Europe. Last but not least, here we are. I am Andrea Perego. I'm a management engineer. I'm the project manager of the ECOFACT project, and I'm here with Alder Moriggi, the leading engineer of the Forge development part. But we are here only as a representation, only as speakers, because we are representing actually a wider team. So we want to thank everybody for the nice work they've done until now. But now let's focus on the project itself. So let's have a project overview, and starting from the targets, understanding how is the consortium made, etc., before deep diving into the solution made on Forge. So let's start with an overall Gantt. Why I want to start with a Gantt? Not to, let's say, to analyze it in detail or understand each task, because as you see, it will be pretty difficult, but just to say that we are halfway. So the project is still has 2 years. 2 years. So we are presenting some results of the project. Some other results will be presented at the end of the project. So stay tuned, because maybe you will find us presenting the further result on the project in the next years. So let's start from the objectives. So the targets of the project itself. There are very specific scientific technological objectives defined since the very beginning of the project, and I want to focus on the second scientific technological objective, because is the objective that is let's say impacted by the solution, impacted by the energy research management system. So basically implementing our solution, so the energy management research management system, the final aim is to cut on the factory energy bill by an average of 25%. So it's an important target. I would also want to focus on the third scientific technological objective, because it's always linked with the sustainability, because in this case is thanks to life cycle cost life cycle analysis and life cycle cost assessment, reduce environmental footprint of manufacturing processes by an average of 4 or 8%. Alongside these specific objectives, there are other objectives. There are other scientific technological objectives, more high level. So basically, these objectives are saying that we need to deliver something at the end of the project. So we need to deliver a platform, as I said before, a platform that should be at a technological readiness level 7. What does it mean? Technological readiness level is a scale from 1 to 9. And 9 means that the solution is 100% marketable, so is ready to be marketable. We have to deliver a solution at technology readiness level 7. It means that the solution should be tested in relevant environment, but not 100%, still not 100% ready to be scaled, to be marketable. There are other non-technological objectives. In general, we could say that we need to exploit the result of the project and disseminate the result of the project. We are doing it also now. We are disseminating the results of the projects. And now let's focus on who we are. So who is carrying out the work? So the consortium is made up of 20 partners from 7 different countries. there are 5 research institutions, 8 large industries, 5 small-medium enterprises, and 2 associations across the manufacturing environment. But let's focus on the real protagonists of these projects, so the demo sites. So first of all, we want to underline the fact that we wanted to test the solution on different industrial environments. So from one side, we have a discrete manufacturing demo site. In this case, we have Arcelic, which is a washing machine factory located in Romania. There is Tofas, which is an automotive factory located in Turkey, and it's part of the Stellantis group. While from the continuous manufacturing sector, continuous manufacturing industrial environment, we have Athenian Brewery, which is a brewery, so a factory of beer located in Greece, and it's a brewery from the Heineken group. There is Goulion, which is one of the largest biscuits factory in Europe, and is located in Spain. Okay, which is the architecture of the solution we are thinking of? Basically, we will start from the factories. So we will start from the data of the factory. So from one side, we will take data exploiting existing data, existing systems already in place in the factories. And from the other side, we will put in place, we will implement new sensors, we will implement an Internet of Things infrastructure in order to collect other data. Then this data will be delivered, will be conveyed to a data broker, and the data broker will harmonize, will clean the data and distribute the data to the application and services layer. In the application services layer, we have our energy resource management system that is composed by different modules. We will see later which are these modules. And from the other side, we have also, always in the app and services layer, the dynamic LCA and LCCA systems and supply collaboration system. So this solution integrated will make up the holistic decision support system, so the ECOFACT platform itself. So it could sound a little bit complicated. So we wanted just to sum it up, focusing on the 4 milestones. So from one side, we have the local data. As I said before, local data taken directly from the field, from the factories, leveraging existing systems, existing PLC, existing SCADA, existing sensors from one side, and from the other side, putting in place specific IoT architecture in order to measure and convey other specific data. Then we have the data broker. The data broker is used, as I said before, to convey data to the different applications and services. In this case, the data broker is based on a software platform called Kafka. Then we have, from our point of view, the most important, let's say, from the user point of view, also part that is the holistic DSS, because it's where the different algorithms, the different application and services are hosted. So from one side, we have the Forge-based digital twin platform that will operate as an energy and resource management system, as said before. And always, as said before, the supply chain collaboration and LCA and LCCA services. In this case, based on always an existing software solution called CIMA Pro. And then we have the last part that is still very important, that is the user interface, which will be used by the final user to interact with the platform and to have access to different data. So now let's deep dive on the digital twin platform itself. But first, let's clarify, at least from our point of view, let's clarify what a digital twin is, because it's very it's a common trend talking about digital twin. We wanted just to focus on the definition from Dr. Michael Greaves. Dr. Michael Greaves said that a digital twin is a sensor-enabled digital model of a physical object that simulates the object in a live setting. And that means basically that the digital twin is the digital representation of a physical asset, of a physical object that could receive real-time data and then simulate the behavior of the asset in the real setting in a digital environment. So as we can see also from the picture, the schema below, the element scale, we talk about digital twin only when the digital asset, the digital model, we can call it, is enabled to receive data directly from the field. So we are referring to level 3 in this case. Then there are further levels that are let's say linked to the fact that the digital twin from the other way around could control the physical asset itself in a semi-automatic or automatic way. So we're talking about level 4 and level 5. Okay, but now let's go back to our project. Let's focus on our digital twin and understand how is it made. And to do this, I leave the floor to my colleague, Alder Moriggi. Please, Alder.
Thank you, Andrea. And now I'm going to talk about the digital twin platform that is composed by 3 different components. So the digital twin itself, then the 3D part that will be visualized with the Forge viewer, and then that we have modeled using Inventor, and all the relevant documents related. Then in the web platform, we have also different tools. Here we specifically mention Optimist because it's one of the tools that we are going to show in this presentation. But there will be other tools linked. There is also the data exchange layer composed by some APIs. And so basically the platform exchange data with the other systems. Basically the data broker that will be used within the holistic decision support systems. Okay. To model all factories lines, Tofaş, Arçelik, Guyon, and Athenian Brewery, we used Autodesk Inventor. Machineries and the products are combined into an assembly to create the whole lines. And after modeling activity, models were uploaded within the digital twin platform in Forge. Okay. And we also use the integration with the Leica technology with BLK3D, a Leica device that realizes 3D photos thanks more photo cameras and a laser that calculated the distance from the machinery. Measurements are readable directly on the 3D photos, and the job inventor is easier. Okay. And in this case, represented in the slide was Athenian Brewery demo site. And we went to Athenian Brewery demo site and we took measurements, and then we modeled a line using these measurements. Okay. And this is the result, what we have uploaded in Forge, but you will see it more in details in the next slides, in next video. And now I'm going to show you the web application that we built for ECOFACT project as a front end to manage factories and all data related to factories. I'm talking about groups, users, permissions, models factory lines, documents, etc. And factories lines we modeled are Tofaş, Arçelik, Guyon, and Athena Brewery, and 2 demo sites. And as I said before, we used Autodesk Inventor. For Tofaş, until now, we have finished modeling 5 production lines, and then we have uploaded on Forge Bucket on ECOFACT platform, Eisenman ECOT line, and water-based top coat line. For Arçelik, we made 1 production line. 1 production line is completed, and another one is almost ready. For Athena Brewery, we made 2 machineries, and for Guyon, we are still working on 2 assembly and 1 assembly with 3 production lines is almost ready, and for the second one we started working on. Okay. And in a specific section on the web application, we disposed an interface to upload the inventors model on Forge Bucket in order to display them on a Forge viewer. To charge model, user has to package all assemblies and parts in a zip and then upload it on a form that use model derivative APIs to upload the source file to OSS and translate the source files. Okay. Okay. In the video, after modeling activity for 1 production line of Tofaş factory, in Inventor we placed the sensors next to machinery like ovens to monitoring natural gas, pools to monitoring water consumption, pumps and motors to monitoring electrical energy, and there are also sensors to monitoring hot and chilled water and steam consumption and compressed air. We are mapping and codifying the sensor in order to get data coming from database and web services developed in other work packages. We have also prepared connectors to get data from sensors. And finally, we prepared, as you can see in the video, a custom Forge viewer to view models, and we created a custom extension to get all sensors placed in the model and all components that sensors refers to, as you can see in the right part of the screen. And we used the get bulk properties to do that, a specific function from Forge APIs. And then we prepared a list of sensors on the right, and the user can zoom to the sensors, the related components, and user can also consult daily data graph and also real-time data. This is the first integration, but we have to realize other integrations like that in the other 2 years and other custom extensions. Okay. And here there are I reported the Forge APIs that we used right now to develop the Autodesk part of the project. We use the authentication APIs to allow the application to use other Forge APIs in a 2-legged way. Okay, next, we have to upload models we produced with the Inventor to the Forge Bucket. To manage the directories in the Forge Bucket, we use the model derivative APIs. And then to build the custom viewers I showed in the previous slides, in the previous video, we use the viewer APIs. We use the get book properties to extract data required, especially sensors data and sensors and machinery codes. We also used some extensions like PDF extension. And finally, we use the data visualization APIs to visualize a sensor and data coming from sensor. Okay, Andrea, I leave the floor.
Okay, thank you, Alder, for the presentation of the digital twin platform and how it's made. So now let's focus on a specific application integrated within the platform. The Optimist application, as you can see, is not the only one, it's not the only application integrated within the platform, but is the more mature one. So we will focus on this specific application. So how it works, what is the application about? Basically, is an application that optimizes the minimization of changeover time. So let's say that thanks to the minimization of changeover time, we are able to save time, and not only time, as we will see from the next slide, and redefine the production scheduling accordingly. As I said before, we save time, but not only, because we as we can see from this slide, the time saving corresponds to CO2 emission saving of about 16%. This is an important results from our point of view and from the project point of view. We have applied this technology, this algorithm, this application for now in different demo sites, but the results are now recorded specifically especially for the Athenian Brewery demo site. And as I said before, this application is directly integrated in the ECOFACT platform. As you can see from the tool section, you can access the application. You have to input some data about the consumption, about the production, about the cost. Then the application run, and as you can see, you can have access to the result of the application in an Excel format if you want, representing the new scheduling, the optimized scheduling of the production, or also you can see the representation of the data displayed directly in the Forge platform. So as I said before, this application has been tested in different demo sites. We have specific results from Athenian Brewery, but also we have been testing this application in Goulion demo site. In this case, it's always the result is always the minimization of the changeover time, and so we will have a different and optimized scheduling of the production for each line. In the Arcelic demo site, we have a different approach. So this application will help the decision maker to minimize the energy bill and redefine the production scheduling accordingly. And so defining also an optimized electrical energy asset management plan. Same we can say for Tofaş demo sites. So we have the minimization of the energy bill and the optimization of thermal and electrical and energy assets management plan. Okay, now we gave you a brief overview of the results of the project until now, but let's focus on the next step. What's next? So, as I said before, the Optimist is not the only application that will be integrated within the platform. There are other 4 applications and services that will be integrated in the digital twin platform, and we will focus on each of them very briefly. So, we will integrate a material flow simulation application based on Siemens plant simulation, and a production optimization application based on the Gurobi Solver application, Gurobi Solver software. Then we will develop an integration with an energy simulation for dynamic operation and management, and cost optimization. Basically, we will develop and integrate a predictive maintenance model to optimize the operation and maintenance tasks. Then we will integrate an industrial energy disaggregation component. In this case, we will integrate this component in order to understand the energy consumed for the production of each different product. So it's an energy disaggregation by product. And last but not least, we will integrate the results of our energy resource system, so the results of our application and services developed within digital twin platform with the dynamic LCA, the LCCA, and supply collaboration services developed within CIMA Pro. And these two components composed together will be the building blocks, the technological building blocks of the overall holistic decision support system. Okay, but what's next? What's next from a call to action point of view? Let's say that the ECOFACT project is open to receive feedbacks, is open to receive to welcome new partners. So for exploitation purposes, we are looking for 5 other demo sites where to test the solution. So if anyone is interested to test the solution on a factory, on a specific factory, is more than welcome. We are looking for also for partners who wants to help us develop further the solution to reach full marketability of the solution by 2028 to 2030. So we are talking about TRL 9, so technology readiness level 9. And last but not least, if you want to get a deeper knowledge about the project itself, please download our handout. If you want to be updated on the development of the project, follow us on LinkedIn, on Twitter, on YouTube. You can subscribe to our mailing list. And if you have any specific question, please drop us a line to me or to my colleague Alder. Okay, so I want to close this class with this quote, because as I said before, as one team, we have been working in different research and development projects, and it's hard. It's not easy. Sometimes you feel lost because it's not easy to start from a white paper and develop something new, and develop following new paradigms. But it's very challenging and very satisfactory when you manage to do it, and it's the only way for real evolution, and it's the only way to tackle and to face and to solve the challenges we are all facing. So our last sentence is: do not go where the path may lead, go instead where there is no path, and leave a trail. Thank you, everybody, for the attention.